Good morning. My name is Matthias Mohr. I'm an independent software engineer, recently more specification authoring person. And there was some echo. Anyway, but I'm... Does it still work? Good. And I'm contracted by NASA to work on CEOS-ARD. And I'm talking about that today. That's a bit, well, dry maybe for some. It's not that technical, but let's get through it. So first of all, what is CEOS? CEOS is the Committee of Earth Observation Satellites. And that's pretty much like all the national space agencies and the satellite operators, forming a union to define and work on satellite imagery. It's currently 60 national space agencies and associate members, which in total operate 190 plus active satellites and instruments all over the world, or pretty much in space. And then they are grouped into several different groups that work on different things, and one of them is the Analysis Ready Data Oversight Group, which is leading the CEOS-ARD development. And CEOS-ARD is one of the, let's say, products that they, or specifications that they define, which is right now, because it's a Committee of Earth Observation Satellites, is satellite data specific, of course, but doesn't necessarily need to be in the long run. CEOS-ARD is processed to a minimum set of requirements, so that's pretty much analysis-ready data for you, and they write the specification, and then the space agencies and others can make their data available under these requirements. It is optimized for immediate analysis without minimum upfront effort. So ideally, you get the data and you can just start with it. The way CEOS-ARD is structured is that they define so-called product family specifications, short PFS. For example, one of them would be surface reflectance for optical data, or INSAR for SAR data. And then each of these PFSs consists of parameters, so a set of requirements that the data that you want to publish as analysis ready needs to fulfill. And each of the requirements can have required optional parameters, and currently they are called threshold or goal. So threshold is required and goal is optional. And these specifications are written by domain experts and have grown organically over time since 2017. You may have known them in the past under the name Card4L, currently called CEOS-ARD, and the website is here at the bottom if you want to get more information about them. There are currently, how many are that? 9 different PFSs released. So for optical, we have surface reflectance, surface temperature, aquatic reflectance, and nighttime light surface radiance. And then for SAR, we have normalized radar backscatter, polarimetric radar, ocean radar backscatter, geocoded single look complex, and interferometric radar. And these are the specifications that they currently work on. These are all pretty much on the level 2, I would say. And then there are currently 21 data sets reviewed that fulfill these requirements by certain agencies. And there are many more than 21 currently in development. How does this look like in practice? So if you open these documents that are currently written by CEOS-ARD, they are authored right now in Google Docs, let's say, in the background, and then you get like these big documents in Word or PDF, which have a long list of requirements that you need to fulfill. This is an excerpt of like 4 of the probably, I don't know, 50 to 100 requirements per PFS. And as you see, they are divided into different parameters, and these individually have threshold and goal requirements, which are either like threshold, so required, or optional, which is goal. And so right now you have a big chunk of a document which you need to implement, right? And when you define a new PFS, which is similar. You need to copy the whole thing and make small changes, but then you duplicate everything. This doesn't really scale. We already have 9 PFSs. There should probably in the future be like maybe even hundreds. So in that sense, this really doesn't scale with like just writing Google Docs. The consistency will not be there anymore. People change things over time, and then in the end, you have not really analysis-ready data anymore because everything is different. And at some point, you would want to fuse data as well, and then it becomes a problem. Yeah, that's pretty much already the status quo that I described here on the slide. But on the other hand, of course, it's an established way of making these data available in analysis-ready ways. And there are data sets that can be used right now and are analysis-ready for you to work with. But as I said, it is just not workable in the long run to do it like this. Consistency is not there. You have like a lot of documents which you need to maintain over time and so on and so on. The whole process is not scalable, both from the authoring sides of writing these documents, and then on the other hand, there is like the way each data set that you want to make available under these PFSs needs to be reviewed at some point and be checked. And that is a bothersome and annoying, lengthy process as well. It's a lot of manual work. In the past, it has been a lot of printed papers that were like, people wrote some things on it and connected bits and pieces from printed metadata documents and so on. And I mean, that just doesn't work in the long run. No one wants to do this work. It's just tedious. So the proposed solution, CEOS is working on making this better over the long run. And as I said, it's rather like boring because it's a lot of specification work. Chris mentioned that before as well. But someone needs to do the background work, of course, and that's what I'm doing. So the proposal is pretty much to use building blocks. We've seen in the past that, for example, Stack works this way. We have a very slim specification and a lot of extensions that people write and then implement whatever they need in the end. We have really small definitions of individual fields that you can implement and make available. And as such, the reuse is very high. So these building blocks need to be atomic, of course. They need to be small so that they can be reused. If there are too many information and too many specifics for different things, it doesn't work. So it needs to be very small, and I'll give examples later. Then, of course, you may need, additionally, in the long run, also some kind of mapping from these requirements that are written textually to metadata, for example, to the stack properties or to some kind of XML metadata spec, whatever you implement. And then, the long run, also, the authoring that's done currently in Google Docs, there is things like citations, references, glossary entries, dependencies between these different requirements, and so on. And these are currently all made manually and don't really work at all because, well, it's just one of these PFSs usually has like 50 pages of text or something like that. So who wants to oversee all that and see whether it's consistent? So that should be automatic. And then in the long run, as you've seen, there are a lot of PFSs right now, and these need to be realigned over time so that they are actually consistent. So how does this look again? We had this before. So for example, in the new building block approach, these blocks here, the red one or the green ones, could be individual building blocks that you define and then reuse across the different PFSs. That's how it looks right now in the working phase. So you describe all these building blocks in a YAML file pretty much and give information about what the title is, what the requirements are. You give information about what the dependencies are, like which of these building blocks, other building blocks that you have are required. You give information about what glossary entries you need to render, what references are important. The history, that's also another thing that is an issue in the past. People just wrote Google Docs, and over time they didn't know anymore what they actually discussed, what the governance of all these was. Like, why did we change something? Why is it the way that it is? So information needs to be stored for that as well, and so on and so on. So this is all now also machine readable, which allows any other or more things to happen, like in the background. You can write tooling that generates these documents. You can write tooling that builds forms where people can self-assess their data sets. You can build review things, and so on and so on. Well, that's probably the requirement that is, because I'm here, there is a requirement there for cloud-optimized formats in there, so that all files are provided using cloud-optimized file formats. That's a very small requirement, but that's how it should be, because that's something that is very specific, and you can implement that and can check whether it's the case or not. Then in the end, you compile these different requirements into documents. Long lists of requirements can be written in a YAML file, and you reuse all the different building blocks that you have in various categories. And that, in the end, is combined into a PFS document, which has certain metadata as well to it, like a title, a version, and so on and so on. And then in the end, you generate the Word or PDF or HTML document based on that. And whenever you change something in one of the requirements, you just regenerate all the documents and the changes in there automatically. You can add additional glossary entries, you can fix or change glossary entries, and it's all reflected directly in these documents, right? Without needing to go through 50 different files and change all that. So now that we have these building blocks defined in a schematic way, we can implement tooling. So what is already implemented is automatic document generation. So it generates HTML, PDF, and Word based on Pandoc and other tooling in the background. So you get these documents right now in an easy way. You can regenerate them within seconds. And then currently in work in progress is an editor for PFS authoring. If you know Overleaf from LaTeX document, that's looking very similar. So you have your files on the left side, you have something in the middle. Here's a screenshot where you edit these YAML files on the right side. There is directly rendered version of the PFSs that you can see all the changes within seconds. In the long run, this is meant to be going even simpler, so that you can, don't need to edit YAML files, but just forms, which is, of course, easier for people that are not so technical. And then pretty much in the background, there is GitHub integration. So all these changes that you make here are directly pushed into pull requests into GitHub. Then people can review all these changes, discuss them over time, and either accept or reject them. You have version control in the background, you can discuss them, and so on and so on. And then whenever the merge, the CI is running, is publishing new documents and so on automatically. And then the last point here is that once that is done, the editing capabilities, the last part is, and which is a very manual process, is a tool for self-assessment, so that people don't need to fill Word documents with long tables anymore, but can fill a form and see automatically which and how many of the requirements they fulfilled, whether everything is complete and so on. You can directly make connections between the metadata and the requirements, so that the reviewer in the end can also look into these requirements and self-assessments and just sees, this is a requirement there in the XML metadata or SEC metadata, it's fulfilled. So this will make the progress of self-assessment and reviews much faster in the end, automatic, and you can also, because it's in a database, run statistics on it, how much of the requirements are actually fulfilled by people, which requirements are not fulfilled at all by anyone, so that you may want to rephrase them or remove them and so on, which gives some kind of quality control and reuse, use of these requirements as well. This is now all, like in the past, it was all published, or not really published, but the documents were published, but the Google Docs you were working on were all in Google Docs, hidden from people, not open. You needed to join the LSIVC groups and to be able to communicate with them, to give feedback and so on. So now that's all openly on GitHub. Everyone can go there and just open issues, make pull requests, and request changes and discuss with the people. And there is, of course, versioning with justification for the changes. So that also gives a long-term overview of why things are the way they are. You can always go there. It's github.com, CEOS-ARD, and then CEOS-ARD. You see the structure here. So there are glossary entries in BibTeX that you can add and reuse. PFS documents are there in YAML files. References are there. References are in BibTeX. Glossary entries are in YAML. Requirements, a lot of them, which is relatively similar to Stack. It's just structured in a way so that you can reuse all these different requirements, and various editorial sections like annexes, introductory sections, and so on. The long-term vision is here that the PFSs that are right now in optical and SAR share building blocks that are feasible. That's of course mostly applicable for metadata, because of course the measurement in SAR is different than the measurement in optical. It's just how it is, so they won't be shared. That ensures consistency. You can map metadata languages so that automatic conversion, etc. in the long run could also be a thing. And then we build a framework that can pretty much be used by anyone. So it's not just CEOS that can in the end release analysis-ready data, but also, for example, OGC or ISO, right? This is meant to be a framework for everyone to write analysis-ready data specifications, release data publicly as analysis-ready data, and so on. So yeah, that's the ultimate goal for the, not probably for the next 2 or 3 years, but really the long run. And then, of course, an important part is always adoption. CEOS-ARD and the data sets need to be adopted, otherwise it's not really relevant. So that's a big part here. So if you have data that is not analysis-ready data yet, and CEOS-ARD has PFSs that apply, please make your data available and go through that review process. That's the summary here. So yeah, we create a general framework for ARD specifications, restructure the whole CEOS-ARD product family specifications, ideally in a non-breaking way. So it's just really a different approach to things, how to author and specify things. The requirements ideally don't change at all. We'll see how that works in the long run, but we need to see also where things were different across the, went different over time. And then we have, in the end, a registry of reusable and consistent building blocks. Ideally, we can align that as well with metadata specifications such as stack, right? So that the things are one-to-one mappings. It all simplifies and automates the whole workflow from many stakeholder perspectives through tooling. It's now an open collaboration framework on GitHub. Involvement and feedback beyond CEOS members is strongly encouraged. It shouldn't be an only CEOS effort, and it recommends cloud-native file formats. And that's it from my side.
Yeah, if there's anyone else, I kind of asking questions every time here, but at the high level, could you describe this initiative as say, you get a project requirements document, and this initiative could somehow map those requirements into a metadata specifications, and what appropriate, say, 8.0 observation satellite data would be appropriate for those requirements. I understanding it in the correct way, or please correct me if I'm wrong?
Yeah, so CEOS-ARD is a set of written requirements pretty much. And in the background, with the building blocks, you can now map to metadata specifications such as stack or ISO 1911.5, or the SAR XML meta specification that is defined by CEOS itself. And then through that, you can directly map all these requirements to the metadata. And the tooling can do various things, right? Whenever the mapping is there, you can convert between XML and stack, or you can do whatever you want with it in the end. You can do some kind of validation in the end, whether the metadata is correct, automate that. So yeah, that is the case, right? So that all the metadata becomes as useful as possible and the data reusable.
Yeah, I think that will be a game changer, I guess, coming from project management. Thank you.
I hope so.
I'll just take the opportunity to make a comment again. Thanks, Joe. You've done a really great job. It's really fantastic. I know the folks that you work with, and I think a lot of them are not technical and won't understand the kind of elegance that you're building into this. So I just want to say well done. You're doing great work.
Thanks. Yeah, it's a tough task, right? If you know that, when they have people that are domain experts but not that technical, that convincing them about the new stuff is scary, right? Change is scary. So yeah, you need to do step by step and go slowly and explain what you're doing well. Otherwise, it doesn't work.
Are you going teaching old people Git?
Oh, that's why we have the tooling. I showed them Git, and they said, oh no, we don't understand that. So now we have this editor, for example, right, that abstracts it away. Cool. And it's lunch break, I guess.